So let's take a look at forces acting on an object on an inclined plane. Now, with an inclined plane, we actually end up treating the plane, the incline, as the x-axis, and then of course the line that is perpendicular to that plane would be our y-axis. This means that our axis, which is normally like this, is now rotated at an angle. So we're going to have to be working with angles to be able to break down our forces so that we can resolve them and find our resultant force acting on the object. So let us redraw this with a different color. So we have an inclined plane, and I'll try to make this a little bit cleaner as I say that and I immediately mess up. So here's my angle. Here is my object. Now I'm going to draw the free body diagram using my blue pen. So we know that we have a force of gravity that pulls straight down. Now, because of the angle, in order for us to use this force, we actually have to break this up into components. We're going to have this component right here, which is what we call the FGY. And then we're going to have this component here, which is our FGX component. Now we have a couple of formulas here. FGX is equal to your force of gravity times the sine of your angle. Now you might be asking me, Megan, why is it sine? Isn't it normally cosine? Yeah, normally when we calculate something at an angle, we use cosine for the x. But because our axis is tilted in a way, using properties of angles, we would find that we actually have to use sine for this. And then just similarly, instead of using sine for our y, we would have to use cosine. So these are the special formulas for the inclined plane. Now, of course, there are other forces that act on an object as well, right? So we have the normal force that's coming out this way. Now, the movement of this box, if we just let gravity do its thing, would pull it down the ramp this way. So the movement would be going down this way. And of course, wherever there's movement or possibility of movement, we have friction. Now, friction would be moving in the opposite direction of the movement. So friction is going to be pointing upwards. Now, to find these two components, we're going to use the FGX and the FGY. So, if we look at our normal force, the opposite force is our force of gravity along the y-axis, but it's the opposite direction. So your normal force is equal to your negative FGY. The friction force, now this could be static or kinetic friction, it depends on the situation, whether it's moving or not. This is going to be equal, but opposite to our FGX. So these are our new formulas for finding friction and the normal force on an inclined plane. Now, let's take a look at an example. So, let's say we have a ramp here. I'm sorry, this is an awful drawing. I'm going to draw a sphere. And then I'm going to draw in the free body diagram. So actually, mass is 100 kilograms. We know that the angle is 40 degrees. And we want to know what is the force of friction for the block to descend at a constant velocity. So we're actually looking at kinetic friction. So let's change that up right here. Oops. So the force of kinetic friction is what we're looking for. Now let's draw in our free body diagram. So gravity. Now this ball is moving downwards. So our friction force is going to be this way. We have our normal force. I'm going to draw it in a dotted line just because we're not really using the normal force. And technically we have this one here too, but we're not really using our FGY. We will be using FGX though. So if we want a friction force, we have to use the formula. Friction force is equal to your negative FGX, which is equal to your negative force of gravity times your sine theta. So let's find our force of gravity. So force of gravity is equal to mass times the gravitational acceleration. So 100 kilograms multiplied by negative 9.81 meters per second squared. And that will give us negative 981 newtons. So we now know the force of gravity. Now let's find the force of kinetic friction. So negative Fg times the sine of our angle, so our angle is 40. We will calculate this, and it should give us a friction force of 630.6 newtons. So we can probably round that up to 631 newtons. And that is how you solve questions involving inclined planes and forces.